All right. Good morning, everyone. Welcome to the show. Today we have a very special guest, Monish from CoolAnt. CoolAnt is a startup company in India working with all sorts of fascinating ways to enhance cooling and air conditioning and all these different ways of building with natural materials. And I think I probably came across them when I was living in India, running my own startup. And I was always, in the back of my mind, I was always like, this is the best startup in India by far, just with the technology they're using. What really fascinates me about this is that it is truly a beautiful marriage of ancient inspiration with modern techniques involved with it. So Manish, thank you for being on the show today, and welcome.
Thank you, Justin, for the kind introduction. I'm really happy to be on the show and yeah, discuss about the work that we guys are doing.
Yeah. So tell us a little bit about just what's your background, and because I mean when I look at these projects, it's like it's physics, it's environmental science, it's design and artistry, and it really touches so many it touch history, it touches all these different things. And so tell us a little bit about your background and kind of the origin story of CoolAnt.
So, I'm an architect by training, and but I have a keen interest on you can say technology, computational design, and natural materials. So that has been my go-to things ever since I started this practice. Uh, so the whole idea has been that ever since this ant came up, I wanted to make this a place that is much more than a built environment. And to see how we can bring in different aspects of the habitat through research, through art, and engineering, and but most importantly, like I said, research plays a very important role in the whole process. So we are trying to see how we can investigate uh, some of the things that we all rather assume or take it for granted, saying that okay, now let's say for instance everybody is making buildings and making air conditioners, so why should we do that, or something like trying to question the basics and see how we can find rather simple solutions, nothing too complicated, so that much larger people can use it. So that's, yeah, I mean, that has been the idea and the thought process behind the practice.
Okay, perfect. And I want to come back to that idea of simplicity later, but just go ahead and tell us, like, what is just the very basic understanding or explanation of CoolAnt and some of the core technologies that you're working with.
So you know the whole idea behind CoolAnt is that when we talk about passive design and when we talk about ideas like traditional architecture, as we call it, or the vernacular, it is no more so common. I mean, what we call as used to be the ancient techniques and all what you call as the common sense or the common science, rather. Both you can put it both the same way, the common science or the common sense. It's not so common anymore. It's people like have forgotten the basics of the construction, the basics of why even we need to have windows. As simple as that. I mean, people now, like in windows, are mostly meant for light and also ventilation. Now, when you look at most of the current day buildings, you focus only on the light and the view, but not the ventilation. It's as simple as that, right? So when you talk about this, so our idea has been that with CoolAnt, how do we communicate the basic essence? I mean, it's all about like the basics of passive design, simply like in uh, uh, the logic behind making good buildings to the masses, and how can we take this through as a startup, as an idea, and how can we scale this? Because when we talk about passive or we talk about even architecture, it's always looked at as a service. It's not something that it's not the service is always not a scalable or as a
A
business.
product, right?
And and also like most of the architectural practices across the globe, I'm not talking about just in India, I'm talking about good average size successful firms practices can reach up to 300 to 400 people that in a lifetime, 300 to 400 if you're successful. And much larger companies who are highly successful, like let's say you talk about larger organizations, probably they can go up to 1,000 projects. But that's not the right numbers that we are looking at when you talk about the population and the amount of need that is there for good design. So we
Mm-hmm.
thought probably with CoolAnt, that's also an opportunity for us to break this and take the certain aspects of the design and especially around passive to masses. And for that, we also need to start looking at a different kind of a business model. Probably we need to start looking at how you know this practice and the whole thing as a product. I'm not talking about product. I mean not just the product of CoolAnt what we do. I'm talking about the whole service as a product. How can you take these solutions to masses and make people like much larger, thousands of people like start using it. So the whole idea behind CoolAnt is also, like I said, we have two verticals. One is Ant, which is an architecture practice, but with CoolAnt the idea is that how can you break the stereotypical notion of a practice and how can we reach the masses with the right solutions and help them implement these sustainable and passive solutions in buildings.
And so when you say passive, right? I mean, when I first found Coolant, and I mean, this was I think maybe about 5 or 6 years ago, right when you guys were first starting. I also just noticed you guys clearly just went through a rebrand recently, which we can talk about that. It's fantastic. But I remember the original website and the original like first iterations were very much based on passive cooling and how to cool areas with things like terracotta. And so you're using these natural materials such as
Yeah.
terracotta, and then you're working with water, but you're taking inspiration from beehive structures and other natural structures. And so kind of walk us through like, what was the first iteration? Was ants a part of that, or was it more of bees and ant was kind of the cool name that came up? And obviously ants are very inspirational in so many ways, but tell us about that a little bit.
No, I think thank you for actually pointing that out. Yeah, we definitely did rebranding. That's because the original website what we had is a lot of text, and we always
Mm-hmm.
went about wanting to preach and talk to people about information. But what we heard, the feedback that we got is that it's too much text and a lot of things that you want to say. And we got the feedback that we got is that it should be more visual so that people can connect really quick and make it very user friendly. So now the content is still the same. There's no change in the content, but we tried to make it more presentable, more visual rather, and less text. So that has been the story behind the branding. But when it comes to the ant, yes, ant first always. It is ant, and the inspiration behind ant is that they're the best builders in nature. They stand for a lot of fantastic things. Collective intelligence, which I personally believe in quite a bit, that it's not we are not living in the world of a one man practice or a show anymore. It's all collaborative. Everything that we do, everything that we see is all comes from a lot of beautiful people coming together and working together to create some magic. So and ants kind of they resemble that in a true sense. The whole concept of teamwork, hard work, intelligence, and yeah, and best builders. Like they work with clay. So
Mm-hmm.
so it's all. So that's how the ant actually came up. This one, and then art, nature, technology. So like this, but I would say that ant first. This one,
Oh,
and the beehive is a
that's a
product.
great.
Yeah, and we have, and then we create a lot of products, and we use this all nature inspired designs, and also hence the names that follow, like ether. We have a product called coral, cacti. So these are different products, and we take inspiration from the nature for those products. So yeah.
Okay. And so with let's see, I mean, so with these different nature inspired products, I mean, are you typically finding that, I mean, the difference in the structures that these animals build is actually genuinely better, and then that they're working vastly different. Like you guys have one that I think is super cool, which is based on the pangolin, which
Yeah.
many people might not know. But what's cool about this is it's art, it's technology, but it's also bringing awareness. You know, the pangolin is being hunted to extinction in Africa, primarily for this high demand of exotic medicines in China. And so you've built out this really cool pangolin type of passive cooling or little piece. Do you find that they all work like just based on the geometry that's used and the inspiration that they have a different output that they create?
Yeah, so it all depends on the project, Justin. So I'll tell you. I mean, for instance, if I talk about the pangolin, the purpose behind the installation is, like I said, it's while I think the form is one thing, but we wanted to create an awareness about pangolins. So the inspiration behind the form is also to create that awareness. That itself is a function of it. It's not just the form, because that's when the COVID also just started, and we heard stories about pangolin and the meat and how it is they're facing an extinction, right? And whereas when you talk about the beehive, where the idea is not just about the hive as the form, but also using the hive as the inspiration behind how bees effectively increase the surface area of the storing the honey. So we wanted to use that as an inspiration to increase the efficiency of the water and the evaporation. And the same is the case with we have done another installation called the cacti. Now, cacti are beautifully resilient in extremely harsh climates, and they live on very little resources in deserts. So we thought that's a beautiful inspiration to actually come up with a form and the product that can talk about cooling, because when you talk about cooling, water is also a very important resource. So how terracotta can help in reducing the water consumption, and so that's where the idea behind the cacti came up. Because that's so the idea is that in different cases, we draw inspiration from the form, from the function, from like the performance, and sometimes even how it's beyond the form and the function. Sometimes it also goes to see how things work as an ecosystem. For instance, when you talk about like nature-based solutions, it's not just about biomimicry for the form, but it also by we're talking about how these forests and everything keep the air and everything pure in nature, right? I mean, they have a mechanism to keep taking carbon dioxide and releasing oxygen. It's a beautiful thing in itself. So how do you take that as an inspiration and create products with nature-based solutions wherein you're replicating the same thing, which is man-made, but drawing inspiration from how nature behaves? So that's the idea behind. So it's not always just the form, it's not always function, but depends on the product that we're working in and how we take it. And another thing I'll just tell you, I mean, in nature is such an amazing and a mystery. Simple things. I mean, something. These are things that we as humans we only are trying to understand the behavior. We don't even know the reason why things are a certain way. Like we know that magnetic forces. We know that magnetism exists, and the gravity exists. But what's causing the gravity, the mass, and there's all equations around it. But it's still a magical force that is connecting things together. That's nature. Now, if you look at basic thing, like if you're wearing black right now and I'm wearing white, so you are in a cold climate, I can see that, like you're wearing still like warm clothes, and black absorbs heat and white reflects. I'm currently at peak. The summers are hitting quite crazy in Delhi. So just the color of the surface, even of the same material, changes the dynamics of how the heat is retained or reflected. So for me, that itself is a beautiful, the magical way in itself how nature behaves. The same
Mm,
surface, the same fabric. If I change the color of this, it changes the thermal properties of it completely against
right.
absorption and reflection. So and that's the we both are talking and we can see that's what I'm saying. So there are a lot of things about nature, how things work, and it's just a matter of how to observe in nature how things are working. And because nature has survived for millions of years and it has evolved, and how do we
Right.
learn from the natural phenomena and try to use it in the design? So that has been the thought process all the in the work.
Definitely. And do you, I mean, I think this is one of the most important and beautiful points to make. And I think that's what actually, well, I would say worries me. One of the things that worries me the most is that most climate solutions being proposed by startups and governments and organizations are very reductionistic in their approach, right? They're always looking at just one symptom, whether that, now the big symptom everyone's obsessed with is carbon, but then all of a sudden they'll move to, wait, no, biodiversity, and they bounce around because they're so myopic in how they view the world versus viewing nature as this great mystery that can teach us without having to necessarily completely understand it, but as an inspiration point. I mean, it's to me, Cool Ant is one of the few that is really doing that. I mean, when you look around at a lot of climate solutions, do you see a lot of just like reductionist thinking and not a really holistic nature based solution approach a lot of times?
Yeah, I mean, I can say that maybe yes and no at the same time, because I can see some of the startups like really uh, picking things from nature, but then at the end of the day, when you talk about businesses, I think the business mindset is more about what really sells and what works for the for the sales, and nature based solutions are typically slower in growth process. So what really happens is that when I say nature-based solutions, I think one thing that one needs to have is patience, and which most of the startups and these people do not have, because they want quick returns, and that's how businesses work. And that's one of the reasons probably why we don't see a lot of nature-based solutions, but there are few who are trying to do it. And like I said, but the biggest challenge in nature-based solutions is that one needs to have the patience and the vision for the long term, trying to be at it for long term. Because if I propose that I'm going to make something which is nature-based, or let's say a moss-based purification tower or any of those thoughts, it's not something I can give you until the moss will start growing next day. Even both the customer and also the person who's serving it, they need to have that mindset that this will work over a certain period of time. It takes time for the nature to grow, and this one. So these are some of, like, probably one of the major challenges in nature-based solutions that I can see, or this one, which is why most of the startups and the companies that are coming, who are in the rush for quick outcome, they don't go for it.
Hmm.
Uh, yeah, I would say that probably that's a big factor in design, right? Because
Right.
customers want quick turnaround period for the products.
Yeah, and you have all the pressures and constraints of trying to scale something or bring it up, but it does create a short-term thinking. And so let's move into this direction for a minute, because and then I want to come back to the technology itself, because you actually you mentioned earlier this idea of collective intelligence and that type of thing, which to me, I'm a very big. I do think in the future we need to move more and more, not in the future, now we need to move more and more into open source ideas. And I just saw that you guys were on Shark Tank India. And for those listening who don't know, Shark Tank is in the US probably in like season 20 or 30. It's been around for a long time, but Shark Tank India is very much new. It's, I think, season 3, and you guys were just on there, and I was only able to watch the teaser clip. And when you, in the teaser clip, they put that, it's you speaking, saying that you put all the designs online for people to look at, being open source. And then one of the sharks is like immediately like, what are you thinking, or, with this? And so unfortunately I couldn't see the rest of it. But I mean, tell me what you can about that experience and about their response. I didn't get to see all of the episode.
Yeah, I mean, I one thing that I truly believe in is that uh, there is so much knowledge that when you talk about this, it exists. I mean, even we as we pick knowledge from our traditional, the wisdom that is carried on and forward. And if you're truly talking about sustainability and truly talking about climate change, it is bluntly hypocritical to say that only I am going to do it. I don't want anyone else to do it. And right there, it's bullshit, because that's not how it's going to work. Like, if
Hmm.
you want change, it has to come from many different places, right? I mean, everybody should start doing it. So if that's the ideology, then keeping things close to one is completely anti the theory of, if you're claiming that you are in a sustainable space and you are working on as a climate tech, right? So we made our work and everything, public. We write a lot of scientific papers. We publish them. We put it out there. I have applied for a couple of patents, but then I dropped it midway. I changed mind and said, okay, let me make it open source. I don't want to pursue through the patent process anymore. So I, discontinued one of the patents, but at the same time, still trying to protect certain part of the designs, because they're two different things. One is technical patent and the designs and all that, so that we can still, what do you say, uh, have a certain control on the design, so that we can give it to people and so on and so forth, because there's also the pressure from the investors and so on. So these are some of the things that that we see. But like I said, so I went with this idea to the shark, saying that it is open source and we want to make it open source. So, but they're not really convinced about it. So I think you saw that the sharks claiming it's kind of illogical to have this thought as a business. But I strongly disagree. Uh, I believe that you can still be open source and make a good business. There is so much
Well,
business opportunity for people to grow. Uh,
hang on.
there is lots and lots of business. It's just about how startups can actually come together and make it work. But it is sad that not everybody thinks the same way. So yeah, I mean, you saw what happened. So I think that's
Yeah. No, I mean, it was such a classic moment of like, oh, you really don't have expansive thinking like that woman. It was like, it's like she was only able to think through that classic capitalism view and no other way is possible. And so I was just like cheering you on for that second of like open source, like keep going. And so it's really important though, because it is, I mean, that was one of my questions was it's like, I don't see there being too much of a challenge of, I'm sure there'll be plenty of higher paying clients for architectural services. But the real question, and you can give us more light on this, but I mean, as we come into these large temperature increases, which many countries are already facing, and India in particular is so intense when these heat waves come, and it kills a lot of people, but it all and it reduces your ability to make a living and all these different factors. And the reality is that if this is not open sourced, then it means that the technology can't reach the vast majority of those people, right? These are people who are making $3 to $5 a day, maybe as wage laborers. So it's not going to reach the villages if it's this, hyper capitalistic product. And so tell us about that part. I mean, do you envision building things out in some way where this is in villages and it has the ability, and or I mean, is that kind of the open source idea, is that hey, there'll be some kids in different parts of the country who will see this and get curious, and then they will go out and build these things?
so. Actually, the idea, like I said, the main idea behind the open source thing is, we, we want every house. I mean, the ultimate goal, like personally, the way I see it is that let's not talk about coolant for a moment. Let's talk about the main problem that is there. So the main problem is, with all the changes and the global warming issues and the climate change that we're talking about, I believe that the best solution and the most and it's not the easiest, but I would say that the first and the easy, the best solution is to, if every house becomes in itself climate responsive, it reduces the dependency on and all energy resources and everything naturally, right? That's the best thing that can happen. So let's say if that's the goal, if we have to counter climate change, if that's what we have to do, it means that we have to make sure that going forward, if every house is climate responsive, wherever you are in the world, if you can make it climate responsive, your dependency on energy, resources, everything will come down. So to make it happen, we have to, as a collective, we need to make sure that how we can contribute to make it happen. So, and coolant is one of the solutions. Like, say, let's say that we are talking about passive cooling, we're talking about how this is there, and even as an architect, it's not just about this. We also, the other work that we do, we want to people to pick it up, and houses. I don't know how to put this in dollars or euros, but it's huge. The scale of it, even as a business, and this is so huge, and it's crazy. I mean, if you look at the numbers, it's crazy. So there is no shortage of business. So the idea is that when there is, it's just one has to be smart enough to make both happen. That you can still do good to the environment, and there is. I mean, we are not against businesses, we are not against profitability, we're not against any of these things. But the idea is that let's understand the problem first, and let's understand what is the right solution for that. And to make that solution meet, we need to work backwards. And in the process, if you're able to strike a good business, I think that's a good balance. So that's where we are coming from, saying that the idea is that, okay, now this is how building should be. Now, how can we make it happen? So you share the information, you tell people that this is the right way to do it. Why don't you build? If we can do in the right thing to you, we will help you make it. Otherwise, this is what you should be building or focusing on. And so, yeah, that has been our business model. That's what we are telling people, that we are still doing a lot of work. We are still doing a lot of projects. People still pay us and for the services that we offer. And but wherever we think that we doing a project, for instance, we get a lot of inquiries from quite far off places. They say that, can you help us do it? If we think we can do something there, we say, okay, fine, thank you so much, we will do it. But if we think we cannot reach there, it's quite expensive for us and also for the client to bring us on. We share the information, we tell them that you do it, we will help you make it, we'll share all the information. Please get it done by a local architect or someone whom you can find locally. We will be more than happy to share all the information. Go for it, do it, and then we will guide you in the process. So we have been doing a lot of work like that, and we are happy with it. I mean, we are just like, we see what these guys come up with, and we are pretty happy. So it's sometimes the satisfaction is more than just a profit that you make at the end of the day. So I think so. Yeah, that's the idea. So that we want more and more people to do it.
Right. And so I want to kind of zoom in a little bit more on, let's call them the, the big problems in that working backward. And so from what I can see is that, it's interesting because I would say, and you can kind of give me your take on this in a minute, but I would say that even if we weren't facing climate change, the current technologies that we're using for cooling or heating or all these different you know ways of working with the environment that we do are just these really bulky, technology heavy, energy intensive, and the core issue is that they're not in any way in harmony with nature. They're not more than even the harmony, it's like they're not harnessing the raw power of nature, right? It's
Yeah,
always
yeah,
this kind of, it's this really strong arm, right? Like an air conditioner is just this, like, I'm going to strong arm nature by pumping this cold air, but it's going to cost me, I have to burn coal and all these different things to produce the energy to use that AC. Do you kind of see it similar, of where you're like, hey, even if climate change didn't exist, we would still want to build these because it just makes more sense overall?
absolutely, absolutely. Because see, the whole idea is that you know if we can work with minimal resources, whether it is material, energy, and everything, I think that's the best way to do it. Whether it is for climate change or even otherwise, the best way to do it, harness the beauty of nature, what it has to offer us, and work with as minimal resources as possible. That's common sense, right? I think that's simple. That's to do. But like I
Yeah.
said, common sense is not so common.
Yeah, no, and it's actually interesting. You're the only person outside of like my group of people that I speak with where I love the word common science. I think that's something we have to get back to of, more citizen science, more common science. So with with that, I mean, kind of just tell us a little bit about like, let's just give people a really strong visual. So why don't we talk about the air conditioner and the issues with the air conditioner and why it's not the best idea and how you guys are working to provide a different solution for that.
See, air conditioner definitely is one of the great inventions because it does solve a problem of creating thermal comfort and creating humidity control where it is extremely this thing. But at the same time, uh, it is also extremely energy intensive and it has really harmful effects on the environment. We have seen that just in the last 100 years, air conditioners managed to the amount of energy that goes into cooling has created with the refrigerants and stuff. Like we have seen the problems with the ozone layer. Luckily, that's changing. That is now working backwards thanks to a lot of initiatives by people and all that. And the energy that it consumes and the emissions that it creates because of this the refrigerants, and it is extremely bad for the environment. Well, I think, as like I said, as an invention, it's really cool, but as a solution for the environment, it's really bad. And not just that, it has also counter productive results on our health. Like, we are our skin and whatever we have, we have a natural mechanism to regulate the heat in the body. We precipitate so that we stay naturally cool when it is this. The hair on the body provides the kind of insulation that you need. And with all of this, I mean, by artificially adjusting to air conditioners, the whole body structure is now changing. We don't sweat anymore, and sweating is also a beautiful mechanism to release toxins from the body. Now, because of which, when this process doesn't happen, that's when you see the unhealthy lifestyle, wherein you start people putting on weight, the obesity, because the toxins. I mean, these are things that has what nature has given us. Now, by adapting to this all the time, like I said, I mean, there are two ways of looking at it. One is what is the optimum amount of time that one can actually be in air conditioners. We don't have to be there in at 100%. So can we, like what we are saying is, as a thing, can we reduce the dependency on it, if not 100%, by at least 60 to 70%? It's possible. We can reduce the dependence on air conditioners by 60 to 70%. That completely changes the dynamics. And so we are saying, okay, because if I go to any person, like, we work with a lot of clients and they say that, Monish, I think it's probably too irrational or illogical to say that, we want to leave without air conditioners 100%. I say, okay, no problem. I mean, can you stay without it for 60 to 70%? And a lot of people are happy about it. They say, yeah, that's cool. I think we can do that. So we say, by doing that, if you offer people solutions that, okay, you don't have to adapt to a zero lifestyle, you can still do good to the environment by cutting it by beyond 50% of it. You can still be part of the change, because it's the kind of impact it has on the environment, on the health, is extreme. And also on the countries where it like, for instance, in India itself, like currently the usage is of air conditioners is between 5 to 10%, not more than that, of the population. Now, it is predicted that by 2050, if we continue to move even towards this, you just imagine the amount of power demand it has to generate power, and what kind of an impact it has on the on the government to cater to these kind of energy needs that are coming up. So it's I mean, altogether it doesn't make any sense. I think the only thing that, like I said, I mean, is one has to shift back to the passive and natural methods of cooling the places. That's it.
Right. And so tell us a little bit about that. Like you have these really amazing, I mean, there's so many, I just feel like we can't even touch the tip of the iceberg with the different types of passive systems that come from either, ancient Persia or India. And so you have am I pronouncing it right? The Jalis.
Yes.
So tell us about like, some of those ancient inspirations like that are out there.
It's amazing if you look at all the traditional architecture in the country. Uh, India being a large nation, if you move from south to north, the architecture changes. And it changes with the geographic conditions, the materials available, and most importantly, the climate. Like if you go to the southern part of India, like Kerala, Tamil Nadu, you'll have where it is humid and also extremely hot. So you'll find this the shading devices and jalis which are more linear. So there's an ample amount of air that is coming in, and also the breeze, because in humid areas you need the breeze. That is like really important to be fresh. Air breeze is really important. But then the moment you go towards the west, where it's desert and it's extremely hot, the jalis are designed in a manner that the air, the very tiny punctures, so you cut the light and also the heat, and you use the physics of the building to air enters from wider aperture to narrower, so that it also creates this the what you say the compression of air, so that as it enters it becomes slightly bit cooler because of the pressure difference. So that is what is done in the jalis in the west, and it's beautifully
Right.
done. But the moment you go towards even further north into the cool climates, there you have this the windows. You need the light and also the heat, but you still have to keep it cool. So the walls are really thick, so that they provide the insulation from cool. But you have these windows which are slits that can bring in both the heat and only the heat and the light inside, but not the breeze and the cooling. So the architecture has always been all across, not just in Persia, and of course, I mean, in the Middle East, in Egypt, we have beautiful examples of these the cooling towers, amazing places. Even if you know, I think in Europe, Alhambra, like if you visited this thing, it's fantastic. And how the entire the architecture of it like is works around the natural breeze, the water, the water streams, natural cooling, fountains, and all, but designed keeping in mind the thermal comfort of the person in the building. And but now that's not the case. Like wherever you go all across the globe, you find this similar kind of structures. You go to South Africa or Africa, India, China, you'll find all the buildings in the cities starting to look like one. There is no response to the climate, there is no response to the sun, wind, the elements. I think that is the problem. So if we can
Mm.
like work a little backwards, so I think growth is not always moving just forward. I think sometimes it's a good thing to step backwards and see what we already have and how we can improvise on those things and move forward. So yeah, I think that's how the whole concepts of jalis and these things work. So
Mm.
in Jaisalmer in Rajasthan, we call them as jarokas and jalis. In the similar thing in the Middle East, they call it as mashrabiyas. In this, it's fantastic. I mean, all of these examples are like extremely beautiful that we already have. Yeah.
Right. And I guess for people who maybe want to research these later, is they also come under the umbrella, they would call them wind catchers.
Yes,
Um,
yes, yes. Wind catchers,
there's
this
wind
earthquake
catch.
tunnels, wind catchers, the crazy
Yeah,
examples like that that can.
exactly. And not only are they like these crazy, beautiful, kind of sacred geometric designs, but they're like these ancient windows, like you said, and it's like they were understanding the physics of these things long before our understanding today in some ways, and so it's really fascinating. What has there, I mean, do you travel a lot to go see some of these places? Like I think on your Instagram you had a spot in Turkey where they were building certain types of homes kind of based on beehives, I think, if I'm recalling correctly. But do you like to travel and to see some of these technologies, or are you
Yeah,
just
yeah, yeah. I
super busy?
No, no, no. I do. I love to travel whenever I get a chance, and uh, I traveled a few countries to explore this the architecture and also the techniques that they use. And yeah, I mean, yes, I like to. That's one of the uh, traveling also always gives you good inspiration to learn and from different places. Yeah, absolutely.
Right. So with that like learning part, I do want to dive into that a little bit of I think one of my biggest fascinations with this is not only is it nature based, but I do really enjoy design thinking and just all these different ways to think around a problem. And so, what does that look like on the average project for you guys? I mean, what do the team members look like? What are the backgrounds? how do you guys work through these different things? I mean, is it, is there a lot of physics involved in computer modeling, or, is there, I mean, just tell us about that.
See, we have a really good team composition where we are a bunch of architects and designers, but we also have worked with, collaborate with people from diverse backgrounds. We work with artists, potters, art community, craftsmen, and all that, like for making stuff. But at the same time, we're working with a lot of researchers and energy consultants and energy modeling. So, like talking about the building physics, the performance of the building. So, whatever we do, we try to see. I think something that we have been really enjoying the most is taking this the traditional systems and plug them with the modern softwares and see how the performance is like, and so that we can actually create a database around how traditional systems are effective. And that's something that we enjoy the most, so that we are trying to create this mathematical models to study and make it more concrete and contribute to the research of how the traditional systems are working and how we can even further improvise those things. So that's something that we guys are doing. And to do that, we are collaborating with, we can say, a lot of these the crazy people from the scientific background. We are working with universities on some research projects together. So yeah, these are things that I do, and also sometimes whenever I get a time, I also teach in a university, so that's also a good exchange of knowledge with the student community. So yeah, all in all, I think we do get like a lot of really good team members from engineering background and all to come and collaborate with us on projects. So uh, it's not a typical, I would say, an architecture practice. So there are a lot of research. I mean, this is you can say a lot of movement of different kind of people actually coming and working together. Yeah.
Right. And what does it look like when you hit a wall? No pun intended, right? But like when you guys hit something that you're not able to break through, or you need some sort of alternate thinking. I mean, is there any kind of go-to practices for that? Is it go take a nap, or use some other tool, or what does that look like?
No, I'll tell you something, Justin. Like even now, I've been working on this for like last 7, 8 years on this particular research. I would say 2015, so 9 years now. And even now, I get sleepless nights about. I do some projects, and when clients text me after we finish a project and we give to them, if I get a call, the first thing I assume is something is not working. Something is wrong with this. So they're calling me. I still get those jitters. So the thing is, I think, but that's the reality of it, because uh, you know uh, that it's really important to uh, what do you say, uh, stay grounded and keep looking at things that can go wrong, because we have like a lot of good case studies, but at the same time we get sometimes the craziest of the problems are not the performance, but the craziest of the problems are mostly to do with either the maintenance, or like there's some kind of mosquitoes. There's nothing in our control with mosquitoes, or there is something to do with you can say probably I'll tell you, we did a school. We love that. I think it's one of the best project. Because it's a school for street kids and underprivileged kids. Like I said, I for me that's the one of my best projects. I mean, I personally enjoyed, while I think we're working still, like while we're doing it, because we have done a lot of projects. But that's something, like I said, I always felt that if you teach the students, then they can go and do much more, right? That's there. Uh, but now when you go to the school, these kids are like, they're playing football, or they deliberately take out stuff and they break it for the fun of it. So they, and so things like this happen, and then there's nothing that we can do about it, right? And so these are things like what you're asking, if you hit a wall. So these are things that happen, and we are like, okay, now what else can we do to make it kids proof, or stuff like that. It's an ongoing process. So I think you always have this, but then luckily it's a very good team, so we always have each other's back, and we keep discussing new ideas. How do we do this, and how do we do that, so yeah. But I think this hitting the wall happens more often than you think, because we keep as a research studio, we keep investigating new things, new stuff all the time, and like we something or the other always goes wrong. So we're kind of used to it.
Right. Yeah,
Yeah.
it's like you have those implementation challenges versus maybe like the core design challenges in those ways. And the implementation ones, you can just
Yeah,
never
yeah, yeah.
really, you can never foresee what they're going to be in some way.
Yes,
They're
absolutely,
always,
absolutely.
yeah, having run a startup in India myself, it's just like there's going to be a million of them. There's no way to predict
Yes.
them. The only thing to do is adapt and respond. That's all you're going to get.
Yeah,
Um,
yeah.
in those situations. And so, but very much earlier in this recording, you mentioned like increasing the like I think you said like transpiration or the evaporation. And is that for a lot of these terracotta like cooling designs? Is that kind of the name of the game? Is figuring out how to increase evaporation because that's going to create more cooling rapidly? Or tell us a little bit about that.
It's you know, it's actually controlling it. That's the game changer, not just increasing it. So the game changer in here is that the more the surface area, the more cooling you get, because it, and you're also adding more humidity to the environment. So the game changer, I think, is if you're able to control the amount of evaporation according to the need, using all the the control mechanisms, sensors, and all that, so that you can how much you want to evaporate, how much water you want to run in a system, based on the climatic conditions outside, and how to regulate that. That's the game changer, not just increasing the surface area. Because if you focus just on the increasing, then it's like you're just adding more and more humidity, and also you are increasing more and more water usage. But the other way is, by control I mean you can control the amount of daylighting, you can control the ventilation, the surface area, the amount of water that you're pouring. So there's it's a the balance according to the orientation, the lighting factors, the viewing angles that you get, how much it has to be porous in front of you. So these are the things that create the that balance actually that comes into it. Yeah.
Okay. And so I guess one of the challenge you said like you have surface area as like the more surface area, the more cooling you're going to get, but at the same time you can't just build a giant thing everywhere. So it's working to create a design that has the most surface area with the least amount of space, I guess, right? I mean, would that
Yeah.
be one of the core challenges?
Absolutely. I mean, that's what I'm saying, that totally depends on, we go about the design based on the project, where exactly, that's where the math come into place. So we design it thinking that, okay, this is the amount of water, this is the space, this is the volume. So we need this much of cooling. So how much
Mhm.
surface area do we need, and how much water, and how do we regulate it? So these are the
Okay.
things that we kind of calculate.
And how much do shapes play in this, right? Because a lot of your designs are very beautiful and they have these really beautiful curvatures and different looks to them. Are those just art, or is that also playing very much into the physics and surface area and the whole grand scheme?
No, it's both. It's both. See, the beauty of architecture, I think, is that if you look at Europe, I mean, and I mean in many parts of the world, actually, even in Peru for that matter. So, like everywhere when you go there, the architecture has to be both functional and also beautiful, right? You take the simplest thing like a doorknob, and how artistic that you can make it, but the function, it's a doorknob end of the day. So function first comes first, wherein how, what is the problem it is solving, and then how beautifully we can make it. So that so we calculate first the functionality of it, and then see how we can convert that math into a beautiful object. So because I'll just tell you something. I mean, if you look at the sun, and sun is not a static object. It moves from one to another. It's not like if I do a perfect shading device at one angle, my sun is going to stay there. The sun is going to keep moving, right? So it gives me a range, saying that my shading device can be between 23 to 35 or 40 degrees to be affected. So I can use that math, that range is there, to create a beautiful wave or a curved linear form, to say that I can keep everything within that range, so that I get this beautiful play of light and shadow and move with the sun in creating that. So that's the that's the beauty, because in nature everything is, nothing is static, right? So
Mhm.
that's where the curves and the forms and everything come into play. Yeah.
Right. Okay. And so you you mentioned with like, if you just were to only increase it, then you have this thing of like creating more and more humidity. Um, for those who don't know, my understanding, which is very basic, actually one of the biggest issues with increases in temperature, specifically in certain areas, right? A lot of times, I mean, just for a quick overview, there will be some places in the world that may actually, in some ways, have a perceived benefit of an increased temperature, where maybe they have a little bit less snow and then therefore they have a longer farming season. But in places like India, even the southern United States, like Mississippi, Alabama, Louisiana, there's a thing called the bulb temperature. And this has to
Yeah.
do with humidity. And that once that, as that approaches this increase, it's not just pure temperature, but essentially it makes it to where the body cannot sweat properly, I believe. Um, I mean, is this something that you guys are looking at with the different regions of India? Is this a design challenge for you that you think about at all?
Yeah, definitely. I mean, that's one of the major factors. The wet bulb temperature and the difference between the dry and wet is what actually sets the performance, because that's the most important parameter. And in the design, so we always design keeping in mind this the gap between the wet and the dry bulb temperature, because that's maximum performance that you can achieve in this one. So we always cater to those ones, but Justin, there is also one more very important factor, that we are not, when we are talking about systems like what we are talking about with building envelopes, it's not always just evaporative cooling. We are
Mhm.
talking about shading, we are talking about ventilation, we are talking about the daylighting, optimizing all the three combined with evaporative cooling. So, in holistically speaking, we are talking about four different solutions in one. So, because even shading plays a very important role in cutting the heat and the light into the you know coming into the building, right? So, all of these factors together collectively is what we design as a building envelope, and
Right.
of which evaporation is only one part of it. So, like I said, but definitely we consider the difference between the dry bulb and wet bulb in designing our systems.
Okay, gotcha. And yeah, and just to uh, round out that holistic perspective, I mean, there's even, you guys talk about how eventually on the terracotta and some of the designs that you actually have a moss that starts to grow on them, which is also purifying air, which is a major missing component in any kind of modern technology, that it's a natural air purification in it.
Yeah. So that's the beauty, right? I mean, if you look at it, nature has surprisingly a lot of answers that it's beautiful. Like if you look at it, and there is moss that can sequester carbon dioxide, and while it's a natural formation, when water and terracotta come together, it forms. Now, some people like it and some people don't like it. So we say that it's very easy to control both. I mean, if you like it, you just have to let it be, and if you don't like it, you need to add salts every fortnight. That will make sure that there is no moss. But both are possible. And so the idea is that how do you let these depending on the project. So we have designed systems where both are possible. In certain projects that people don't like moss, so it's okay. I mean, people have their own choices. So we are okay, fine. We don't want moss, it's fine. But some people are like very nature friendly. They want it to be there. So we work
Hmm.
according to that.
Right. And so what does the average client right now look like
Sorry, I'm
for the
losing you.
business? Can you hear me now?
Can you, Justin? Can you hear me?
Yeah, I can hear you.
1 second. I lost you. I think my
Okay.
connection is a little.
Yeah.
Yeah.
Yep. Can you hear me now?
Yeah, I can hear you now.
Okay. Yeah, I think the connection's a little slow on that side, but that's okay as long as you can hear me.
Yes, I can hear. Yeah.
So what is the average kind of client right now look like for this business?
No, it's fantastic. I mean, we're getting some really good, uh, inquiries, and a lot of people are reaching out to us. It's much more than what we are able to cater to right now. In fact, it is a good problem to have, and so sooner or later, if we can find some good investors, I think we will be able to scale much faster, for sure. But the response has been quite warm and encouraging. So a lot of people do reach out to us, in fact, globally, and they're asking us to do so. Like I said, we have uh, currently uh, what do you say projects in different parts of the country, and also like 4 to 5 different countries also. And in India, I think mostly the hot and dry states are something that we're catering to. So yeah, the response has been really good. Yeah.
Okay. And is it a lot of like private homeowners who want to add this? Is it businesses and offices, or I mean, what does kind of the norm look like so far?
It has been mixed. We do institutions, offices. We're doing what do you say uh, businesses, factories, private owners. So it has been mixed. It is a mix. So whenever we get a project, we see if we as a startup, if we can actually do the solution or the cater provide solution to them or not, and then we take forward accordingly. So
Gotcha.
if we think that our solution fits best, then we take it up, or else we don't. But luckily, we have been getting inquiries from quite a different range of products.
Right. And for large, I mean, for a factory and things like that, I mean, there must be a pretty, strong use case with that for them to be so interested in. And so I think on the website it says, like up to 15% reduction in temperature, I believe, or is it 15 degrees?
15 degrees. I'll just tell you, I mean, this is something that people misunderstand, especially from non-technical background. So no matter what, we cannot go below the wet bulb temperature. Okay. So we cannot go below wet bulb. That's for sure. So the thing is, if the temperature externally is in India, if it is 48, we hit 48 like quite easily. For me, it's not so difficult to bring it to 31, 32. There it's already a 15 to 16-degree drop. If the temperature, and but if my wet bulb is somewhere around 26, 28, I can evenly get it up to 30. So if there's a drop of 18 degrees, it's possible. But if my external temperatures are 32 and my wet bulb is 30, I can't even get 1 degree drop. So the performance that is there, is always is depends between the, like I said, that's what I keep saying, that between the what the maximum I can get is less than the dry bulb and the wet bulb. So that's how it
Okay.
works. Okay. So if the dry bulb is 48 and the wet bulb is 32, I can get somewhere in between is the performance that I can get. And that's what physics states. I cannot go below that.
And is that firm? I mean, is that a is is there a possibility that there is a discovery or a innovation that could someday change that, or is
That's
that
physics,
just
Justin. Physics,
it's
like,
just
it's not
not going to
possible to
change?
go without
Yeah.
mechanical. I'm talking about natural means to go below that. Naturally, unless you use some form of mechanical energy to make it happen. So that's simple physics. But so you cannot go below that without additional mechanical energy, like cooling some other solutions and all to do it.
Okay.
So yeah,
So until we break some physics laws, then we can do it.
yeah, yeah,
Yeah.
yeah.
Okay. Okay.
Yes.
Gotcha.
But actually, I'll
Um,
tell you something. But even then, it's quite amazing if we can still get this, because I'll tell you what, uh, we are also working on some pre-cooling solutions for cooling towers and other stuff. So if you are able to do majority of the work on the cooling towers, like if air is entering into a cooling tower at 36, and let's say my system, we added like a pre-cooling because it's quite easy to do and quite cheaper. And if it is really reducing the air at 36 to let's say 30, that itself has tremendous performance on increases the performance of cooling tower, and also reduces the energy loads and the refrigerants and everything.
mhm.
So even that way is this pre-cooling and all of it. It has a great potential in overall reducing the dependency on the air conditioners. So that's a which I think is a great thing in natural nature-based solutions like this, is because, like I said, the goal has always been that how can we try to reduce as much as this dependency on it, but not to claim or prove that we're going to replace it 100%. At least as of now, we don't have answers to that, but that's also has not been the intent to start with.
Okay, gotcha. And I mean, you guys are primarily, I mean, as of now, it's clear that you're very much an Indian startup, but like you said, you have a lot of interest from around the world. Are there any particular areas in the world that you think are just absolutely perfect for this technology for adoption? For example, say like Arizona in the US?
Yeah, yeah, absolutely. There are a lot of places which is hot and dry, the Middle East, Arizona, um like many places, in fact, where it is, our solution is like very best suited.
Hmm. And so you mentioned the hot and dry. Do you one thing that I when I look at some of the current climate maps, which are not always anywhere near correct. There's lots of projections and those get changed all the time. But for example, the southern United States will virtually be inhabitable in probably 50 to 100 years because of the wet bulb temperature, or you would have to be inside an air conditioned room all day, and you wouldn't be able to do any kind of physical labor outside, any kind of construction or agriculture and things like that. Um, do you do you envision more migrations out of these really intense wet bulb areas into more of these dry areas?
Yeah, definitely. See, look at the this climate change is unbelievable. I mean, we are starting to see the things even in cities. Forget about remote areas and wet bulb zones. I'm in Delhi right now, Delhi and Noida. Last monsoons was a havoc. It is
Hmm.
the amount of floods is unprecedented. I mean, we have seen nothing like this before, and the amount of landslides and this everywhere. I mean, it has become a common thing. It is no more a myth. It's quite evident. It's on your face. This climate, whatever happening now, it's not just about people migrating. It is affecting. There is indirect effect, not just about this wet and humid areas, but like uh, it's having global impact. In Greece was flooded a few years back. China was extremely bad last year. We saw this in even UK. I think got flooded quite crazy last year, right? Last year, I think when it comes to the floods and all, we heard uh, like stories like never before. So it is. I mean, it's unescapable. And also look at the situation with. Wars and all of it in a lot of places in the world. They're also not helping. They're also adding more to the global warming issues. So my answer is that it's not just about moving from the wet areas to dry areas. It's just um, we need to find a holistic solution. It's not that simple just about because
Hmm.
it's much serious than as it seems. Yeah.
Hmm. And so for you guys though, why focus on the dry areas more? Is it because that differential of the the increase that you can get, or the cost reductions and the decreases in temperature? It's just because that range is so much better than the humid areas that it makes more sense to go there first.
No, we let's say, I mean, let me put the scenario in front of you. Like when people reach out to us and they come to us from different climatic zones. So when they come from a typically wet area, we tell them that evaporative cooling is not at its best in your location, but still the other principles of shading, ventilation, and this daylighting can still work for a passive building, and we can still do that. And but if you're expecting us to provide an evaporative cooling solution for you, we don't have that solution for you, unfortunately. But we still can provide you the other solutions based on these three factors. But if it is a dry, and which is what people like, hot and dry climate with evaporative cooling, where the performance for the same system is more. If I'm providing the same system in two different places, obviously the temperature drop in the dry is much more than the wet. So we tell them, and we still do able to do in some projects, even if it is a like a coastal region or something. We're still working in those areas, but then we communicate to the people saying that do not expect the same performance from the same system as you would in a dry and hot and dry. A lot of people understand that and still would like to work with us, but it is a responsibility to tell them that I cannot claim the same results from the same system in two different climatic zones. So rest is up to them. However,
Okay, gotcha. What about in terms of like the tools you guys are using? I mean, is artificial intelligence starting to help you guys at all in any way? Do you guys work
soon,
with a lot of
soon,
different models?
soon, I think we are doing a lot of first building a database to collect it, and then eventually the idea is also to use it for predicting the systems in the future, because there is not while I think this traditional wisdom and all of that we talk about is thousands of years old, but when it comes to the data and especially around passive systems is not as concrete as it is should be. So we are collecting data right now, and also the idea is that we collect a lot of data with the sensors and all of it, so that we can predict the systems in the future with the help of these ones. But to reach there with AI and machine learning programs and stuff, we need to first have a huge database, which is
Mhm.
what we are focusing on right now. So yeah, one day we can start exploiting the benefits of AI in this domain.
Yeah. Okay. Yeah, I can kind of see it being like the going back to the initial premise. I very much am interested in mostly low tech solutions, right? Even coming from the farming industry, looking at how the vast majority of farming now is so high tech that the farmer, especially in the US or Europe, they don't have any power. They've been stripped of all of their own personal power because of the introduction of all of this high tech, and they don't have low tech solutions. Whereas you see in the small regenerative organic farming or gardening world, you see all these low tech solutions coming in, which I feel is very much, kind of in one on one side, you guys have this extraordinarily low tech where it's like, terracotta, clay materials, water, and simple designs. But I can also see eventually where the AI can kind of create the like, the queen bee where all this, energy is coming off of, and then it can be disseminated faster to everyone else and more, with more data, more input of different designs for different locations. I can see how that could
Yeah.
be quite interesting.
Absolutely. It is like I said, I mean, so there is this debate about always low tech or high tech. I think both have their own advantages. In scaling, if you have the right technology to scale and take it to the masses, then technology definitely helps. But then at the same time, one should not lose out on the hands on the low tech, that hands on stuff that we can do ourselves. I think you're also saying the same thing, right? Like well, because to scale and to take it, technology definitely has this, but the disadvantage is that you become too dependent on the tech. So
Right.
I think it's just a matter of choice, Justin, and ethics, because how like uh, there is no simple answer to that, because uh, ultimately uh, a lot of the startups and companies working with tech, they hold the control to the data. They're the ones who actually have this rigorous control, isn't it?
Hmm. Yeah,
So
no, for sure. And I think that's what's so unique about this project. And I just wish you all the power and success and good power to push forward in the open source and bringing it to the world in all these different ways. I kind of want to move toward finishing up here. I don't want to take too much of your time because I know you're extremely busy, but I'd like to know, you know, what are some of your other interests that are not necessarily look like they would be aligned with your work, but I mean, is it, fiction, fantasy novels? Is it, just anything outside? I was even earlier thinking I had this question. We can go into this really quick. What is, and I'm totally brain farting here, what is the system in India, the traditional system? Is it Vastu?
Vastu.
or
Yeah.
Vastu, right? And that's where they analyze the energetics of the land and the house, but it also has a
Yes.
lot to
Yes.
do with airflow and other dynamics. Does that play in any? I mean, has that ever been an inspiration for you at all?
Honestly, I'll tell you something. I'm pretty fascinated by this, the subject of Vastu. Uh,
Okay.
and I believe that it is one of the things that holds a strong position in the society, and if it harnessed properly, I think it can help in communicating about the climate and the climate change to much larger audience, because people believe in Vastu far more than people believe in architects. Far more.
Uh-huh.
The kind of
Uh-huh.
impact Vastu has on the society is unbelievable. It's like it's really powerful. I'm talking about coming from the prospect of the belief system. It's a religion in itself, Vastu.
Mm-hmm.
Okay. And so if like if dealt with properly, it really has the potential to talk to people about a lot of these issues in a much more concrete manner. But I also believe strongly that it needs an upgrade, Vastu, because Vastu is built on the fundamentals of the building science, uh, dated back to centuries, like old ago. But now there's a lot of science and everything it has evolved, and so should Vastu should also evolve. But unfortunately, in a lot of places that we see, that people still follow blindly certain Vastu principles, which are, in my opinion, are not. They're dated. They're not uh,
Mm.
so relevant in modern day. So it needs an upgrade, which I think once it happens, I think it's amazing. So, but yeah, it's a very powerful medium for sure.
Right. And so just to give the listener, especially the listener in US or Europe, a little bit more. So Vastu, the simplest way to make a comparison, which again, don't take this as the exact comparison, would be it's probably a more robust version of Chinese feng shui.
Feng
And it
shui,
has
yes.
all of these different principles of energetics of the house and location and airflow, all like you said, it really is a religion in itself. And I have a funny story about this. So we were building our factory outside of Navi Mumbai, right in on the highway in between Navi Mumbai and Pune, and we had probably the absolute best consultants in India for this, and we did build a probably a top five quality food manufacturing facility there. With every major certification from Europe or the U.S. that was not present, and so, one of the core parts is you're designing the process flows of how the factory is going to flow and all these things. And we had these experts and they've done all this work. And then my partner comes in one morning and he just goes, I can't sleep. And he goes, it's the factory. He said, there's something about it that's wrong. And he goes, we need to hire someone who does Vastu. and, and, and what's funny too is he was always, I mean, I don't think anyone can really be born in India and come from India and not have just a
Vastu.
deep, yeah, like a deep religious inclination. But he would always be like, I'm not religious. I'm not superstitious. But then when he came in that day, we had such a good laugh, and he was just like, "There's something wrong with the flow." And I said, "Hey, man, do what we got to do." So we hired a Vastu expert and changed the factory. But I mean, imagine that, right? For people listening, you're talking about a $1.5 million factory that has another probably $300,000 in high tech consultants for process flows, but then we go and hire this Vastu person because that's how much it impacts culture in India, and that's how
Exactly.
embedded this idea is in India. And yeah, it's interesting. Once you said that is it, it probably is one of the greatest ways for you to promote these new models of technologies is finding a way to work within that Vastu affinity that people have, and finding the people who are maybe a little bit more flexible initially, who don't just blindly follow. but
Yeah.
it's super fascinating. Well, cool. I mean, we could go on forever about Vastu, but is that kind of is that a common? Are there other people on the team that have a deep interest in that, or are there some other?
No, I think we all believe that it's a great. I mean, like I said, I'm not. Uh, you know, I am a believer in Vastu, but like I said, that we try to back it up with scientific evidence all the time. We do a lot of Vastu projects, but we don't go by the what the book says. We try to combine it with climatology and the climate science, and combine these two things together and find this intersections where both of them are they can work in sync. So I think that also resonates in the studio because that's what I think collectively we as a team we are trying to push. Because when people come to us for Vastu, we also try to combine. I mean, talk to them about the science behind it and how uh, climate plays a major important role in Vastu, and it does. It is. So yeah,
Mhm.
we do a lot of that Vastu work in most of the architecture projects that we do. Yeah.
Okay, gotcha. Is Vastu? I mean, does that come? Was Vastu a core part of the Vedas, or is
Yes.
it? Okay, yeah,
Vastu
right.
Shastra, it is part of the Vedas. Yes.
Vastu Shastra. Okay, yeah. Wow, a whole different world. Okay, well, I would love to go into all of that right now too, but we have other lives to live.
But
um,
great, Justin. You seem to have a lot of knowledge about in India and all this thing. I'm quite, I'm too enjoying this conversation. It is pretty amazing that you know a lot of stuff about India, the traditional sciences, the architecture. It's fantastic. I mean, it seems you're very well versed with uh, all these amazing things. I'm quite what do you say impressed that you have put in so much research in the sciences. Yeah.
well, it's for me, it's just my knowledge is very dispersed. I don't have the deep type of knowledge that you have, but it's just it seems like the way forward. It's just
Yeah.
so clear to me that it's the way forward. I actually one of the one of the things that really got me into this was I would say about 15 years ago. Um, and this is maybe, yeah, this is during college because I studied sociology and religion, but for my religious studies, I only focused on Eastern religion, so Hinduism, Buddhism, Jainism. I came to India originally and studied for the summer with a Jain community.
Wow.
Um, and but I was never the best student. Most of it I forget, but it was great experiences. But I went to a conference in San Francisco for Earthships, and Earthships were really my first introduction into a alternative building designs, and that just blew my mind. And over the years, I've just kind of kept track of, okay, what are the other things happening, and that's why when I found CoolAnt, it was just like, wow, this is kind of for me the pinnacle of a startup working in this space. It was just it blew my mind. And so yeah, I've had a lot of fun too. We should do another one, and we can talk about all the different uh
Sure,
you
sure,
know
Justin. I'm really loving this conversation. I'm sure. I think we should plan another one.
yeah,
And but
definitely.
yeah, like do visit India sometime again, and we would love to host you here. It's good to.
Yes.
We would love to hear your experiences in India, and what are your inspirations and your travel stories. Yeah.
Yeah, well, now my connection there is when I left, I actually started studying herbal medicine, and so now my big connection back to India is Ayurveda. And so
Wow. So
working
when
with
was it like that
Ayurveda.
you left from here?
Excuse me, sorry. I'll have a lot of editing to do on this podcast. Uh, I left pretty much a couple, like 2 or 3 months right before COVID really hit.
Okay.
So I got back to the US, and I probably only had 1 month in the US until they kind of started locking things down. So I left right before then, but then I was there Originally, I consulted for a one of the largest California almond companies, um, which we has all of its own challenges. But then actually through that, I met my business partner. He was one of the largest importers and buyers of California almonds in India, based in
Okay.
Mumbai. And he was just always the smartest guy out of all the people I would talk to in the market there. I would talk to 10 to 15 different buyers every day, a lot of them being located in Old Delhi in the market there.
Okay.
But this guy was just always the most intelligent. We would talk for an hour, and he would say, do you think Amazon's going to work in India? And I'd go, absolutely not. He'd go, you're right. So what is going to work, or how is it going to look? And we would just have these conversations about how are things going to transform in India? How will it change? And at one point we decided to start this snacking startup. But the whole time, the beautiful part was just being so steeped in everyday India culture. It was much different than being a tourist, where you're
Yeah.
kind of going around it. Every day I was in an office with, my Kerala coworkers and employees, and someone from North India, someone from Tamil Nadu, and just the different
Fantastic.
experiences and culture and everything was just such a wonderful
Nice.
experience. And so it added so much to my life that, yeah,
Fantastic.
but I would love to come back and
Yeah, yeah.
see
Please,
some
please
of
do
these
come.
things.
We'll be happy to have you here, host you, and yeah, like I said, fantastic. I'm really happy that we're having this conversation. Seems like you had a great time in India. So
Definitely.
nice.
Yes. I will see you, but I will not see you during monsoon or the summer. I'll be there in winter. That's for sure.
Yes, yes, yes.
Okay, well, Manish, I'm going to let you go, but thank you again for this wonderful time.